So, ayan. Good afternoon, guys. So, our topic for this week is technically a continuation siya ng topic natin last week. So, let's proceed na with power. So, what is power and ano yung relationship niya? Tsaka how we technically use power. Power in a sense of thermodynamics, ha? Not what Cersei Lannister talking about here. Okay? So, let's proceed now with the definition. So power is technically, it is the rate of work done or energy used. Okay? It is the rate of work with respect to time. Okay? Power is equals to work over time. Okay? So from this idea, technically we can come up with a formula from calculus. Di ba? Actually, mga ganon. So ayan nga. Change in work over change in time. So when it translate to calculus or derivatives, so pakita natin lang din. Let's say we have a function of an equation. Let's say we have an equation. Okay, that like here. Okay. So yeah. Function of x is equals to work. Diba? Para ganyan. Work. So ano ang formula ng work natin? Force times distance, di ba? Let's say we have that kind of work. So technically, once you derive it with respect to time, so function of x with respect to time, so magiging derivative of work with respect to time, di ba? So some of technically some of real life application ng calculus, which is mababanggit siguro sa inyo once na na-take yun na yung subject na yun, is that rate of change. Technically, calculus is all about rate of change. Pero baka napapalay tayo sa topic. So technically, when we derive work with respect to time, we come up na with f of x, or the first order of derivative of work is equal to power. Okay? Which is, yun nga, work with respect to time. Okay? So, ayan. So, yun nga din. So, nabanggit din dito, power is technically the rate of transfer of energy. How you transfer energy with respect to time. Kung kailang, ano ka ba? Ganon, di ba? So, ayan. So, balik tayo sa PowerPoint din ulit natin for other, ano. So, makikita niyo sa PowerPoint, guys, meron nga doon, power is equals to work over time. Or, we use the Greek letter delta, which means change, delta W over delta time, or change in work, change in time. So, nagiging parang once we use the term change or delta, yan, D. Technically, nagiging work 2 minus work 1 minus time 2 over time 1. Parang ganon. Okay? So, ayan. Dagdag ano lang din naman yan. Dagdag knowledge na lang din. Okay? So, ayan. So, makikita nyo guys, kung nakita nyo sa kulay red, di ba? Meron tayong, ano dyan, tawag doon, break down natin yung formula for work, which is, ano yung formula natin for work last week, di ba? We have work is equals to force multiplied by distance. How much force you apply to a certain object through a measurable distance, di ba? Yun yung definition niya way back. So, di ba, kung ganyan, so technically, power can also be translated or can be breakdown or can be computed by force multiplied by distance over time, and then power is equals to the force multiplied by the velocity or the speed na na-create ng force natin. Okay? And then, meron tayong konting cheat code dyan, how to solve power. So, technically, power is equals to work over time. You just need to, pakita natin. You just need to, spotlight. So, ito, di ba? Work, power, time. So, yung sarado mo lang yung work. So, if work ang hinahanap, multiplied mo lang yung power and then time. Power multiplied by time, you can have work. And then, if you're looking for seconds, how many seconds? Ganon, di ba? So, work over power, you can compute time. Okay? So, ito na yung pinaka-main definition ng power when it comes to thermodynamics. Okay? So how fast or how slow or what is the rate of work done or how fast you transfer an energy. Okay? Syempre, di ba? Hindi man pare-parehas tayo. Hindi man tayo pare-parehas how we transfer the energy. Okay? So, ayun. So, next tayo. So, next is yung mga units na meron tayo. Okay? So, first, check nyo muna yung kulay ano? Yung kulay red na ano muna. So, ayan. So, okay. Mapapansin nyo, pinakita ko yung breakdown how we get the unit. Technically, the SI or the System International Unit for SI or for power is technically watts. Okay, watts or watt. Courtesy of James Watt. So, ewan ko kung alam niyo yung contribution niya. Technically, ang pinakamagandang contribution niya is yung steam engine. Okay? You can check it on your internet para sure tayo. Pero ayun, I'm pretty sure it's because of the steam engine. Okay, so technically, because of steam engine, pumasok tayo sa revolutionary era. Parang ganun. Okay, so sort of history na yun. Konting mema lang. Anyway, so ayan. So, di ba, we have technically force multiplied by distance, which is work, and then unit for joule, di ba? We have the unit for work is joule, di ba? Naalala nyo, or foot-pounds. And then technically, joule over second. So, tatandaan nyo, 1 joule per second is equal to 1 watt. Okay? 1 joule per second is equals to 1 watt. So, ayan yung mga unit natin for power. So, for power in SI, we have HP, not Harry Potter. Okay? It's, pero although there is, tawag doon? Reunion movie for Harry Potter. Okay? So, horsepower, ayan, nakabanggit naman dyan. HP means horsepower or watts. So, in watts, we can have kilowatts and so on. Di ba? So, ayan. Next, sa English, technically, basic lang siya. Foot-pound per second and foot-pound per minute lang yan. Okay? Technically, we don't have inch-pound kasi sobrang liit na nun. Pero ayan, foot-pound per second and then foot-pound per minute na lang yon. And then conversion, we have here, yung conversion natin is related to 1 horsepower. So 1 horsepower is equal to 550 foot-pound per second. 1 horsepower is equals to 33,000 foot-pound per minute. And then 1 horsepower is equals to 746 watts. Okay? So yan yung mga gamitin natin na conversion for power. Okay? So horsepower, foot-pound per second, foot-pound per minute, and then 746 watts. Okay? So, syempre, when it comes to application, guys, di ba? Technically, same lang din yan nung discussion natin last week about work and energy, di ba? So, pinaka-main application ng power is, of course, our gas turbine engine, okay? Or reciprocating engine, or pinaka-general, our power plant. Okay, yung makina mismo ng aeroplano is the basic or the most foundation or pinakamadaling way to explain how power affects aircraft. Diba? And then, yun nga, we talk about thrust. So technically, thrust sometimes can be translated into, ayan, horsepower, mostly horsepower or pound force, madalas, pero ayan, yung madalas na ginagamit natin na, okay? So, mabilis na topic lang tong power, and then we proceed now to we proceed now to problem solving. Okay? So ayan. So we have ilan to? Five sample problems. So first, raising an elevator from the bottom to the top of a building requires 950,000 joule of work. And then the elevator takes 50 seconds to reach the top. So how much power was used to raise the elevator? I-note natin, raise the elevator to the top. Okay? So, ayan. So, madali siya, di ba? So, solve natin. So, ayan. Burahin lang natin to. So, power. Sample problems. Okay, number 1. So, meron tayong work given, which is equal to 950,000 joule. Okay? And then, meron tayong time given to reach the top, which is equal to 50 seconds. Okay? Next. So, ayan. From here, di ba? And then, power. So, how much power yung ginamit ng elevator? Okay? Or anong mechanism man yung nagpapaandar sa elevator natin? Okay? So, ayan. So, next, power is equals to work overtime nga, di ba? So, 950,000 joule all over 50 seconds. Okay? So, next, solve natin. Ilan? So, magiging 19000 watts. Okay? Or watts na lang. Pwede naman yan. So, ano yung final answer natin? So, it takes a 19,000 watts to raise an elevator. Diba? Okay? Madali lang siya. So, wala siyang kahirap-hirap. So, next tayo. Next problem. Okay, so if kung may question kayo sa way of solving natin, feel free to chat or mag-react. Okay, and kindly close your video. Just in case lang, kung naka-open. Okay, next tayo guys. How much energy is used by a 60-watt light bulb that has been left on for 8 hours? So, how much, kung gaano kadaming energy yung nagamit. Okay? So, may ano naman, may power na given and then may given na time. Okay? So, number 2. First, we have power which is equal to 60 watts. Okay? And then meron tayong time na 8 hours. But technically, di ba? But technically, di ba? Ano nga tawag doon? Formula na 1 joule per second is equals to 1 watt. And then ang nasa given natin is naka-hours. So need natin siya i-convert into seconds. Okay? So seconds 36 1 hour. Okay? So 8 times 36 which is equal to 28,800 seconds. Okay? So, yun nga, power is equals to work multiplied by time, and then power multiplied by time is equals to work. So, transfer ko lang yan siya dyan. Or, you can remember the triangle. Okay? Wait lang, ayusin natin yung drawing ng triangle. Pwedeng ano, yan. Actually, parehas lang din naman yun. Okay? If you don't know how this one works, you can try the triangle technique. Okay? Work, power, time. Okay? So, from here, so 60 multiplied by 28,800. Okay? It's equals to work. So, times 60, which is equal to 172,800 joules. So, ayan kalaki yung na-exert na work no ano natin. Okay? So, ayan. Okay? So, ayan. Next tayo. Okay, so I hope malinaw pa yung mga topic na to. Yung mga part na to kasi hindi pa naman siya ganun kaano. Okay, next tayo. Next problem. Okay, maaraw na. Nice balls. Okay, next. What power will be needed and also horsepower? So, answer dapat natin in horsepower. Binanggit naman dyan. To raise a GE90 turbofan into a position to install it on a Boeing 77-300 airplane. So, technically, the engine weighs 19,000 pounds and it must be lifted 4 feet in 2 minutes. So, check natin yung mga given. Okay. So, from the term itself, it weighs, technically mass yan, pero The weight yan. So we have weight which is equal to weight yan hindi yan work. Weight na equal to 19,000 pounds. Okay? And then may height daw tayo na 4 feet and then with a time of 2 minutes. So, paano na yan? Technically, hindi na siya direct solution. Di ba? As we remember, power, di ba? Always remember that power niya. Power is equals to work with respect to time. And work is equal to mass. Di ba? Work, we have many formula for work. We have work equals to force times distance. Or we have, tawag doon, 1/2 mv squared, di ba? Or we have the formula for potential energy, which is mass times acceleration times height. So, mamili lang kayo kung anong formula for work natin. And technically, mass times acceleration due to gravity, weight is equal to mass times acceleration due to gravity. Then technically, work is equal to weight yan weight multiplied by height. Okay? So, ayan na. Na-work around na natin or na-way around na natin yung problem natin. So, power is equals to, so convert muna natin to into, actually kahit hindi na kasi, di ba, we have units for English units, either seconds or minutes. So, as is na yan. And then, convert na lang natin into horsepower. So, power is equals to weight times height, okay, all over time. Okay? So, ayan na yun. So, 19,000 multiplied by 4 multiplied by 2. Divided by 2. 2 minutes. Okay, which is equal to 19,000 times 4 divided by 2, which is equal to 38,000 foot-pound per minute. Pero, sabi sa problem, balikan natin yung problem, guys. Ang sabi sa problem, what power would be needed in also horsepower? Technically, what in what value in horsepower? So, need natin i-convert yung nakuha natin na 38,000 foot-pound per minute into a horsepower. So, ito yung conversion na meron tayo. Balik tayo dito. So, ayan, we have this conversion, which is, ayan nga, 1 horsepower is equals to 33,000 foot-pound per minute. Okay, so 38,000 foot-pound per minute multiplied by foot-pound per minute sa baba. Okay, always, kung ano cancel out mong unit, yun yung nasa denominator. Okay, horsepower. So 1 horsepower, 33,000. Okay, which is equal to 38,000 divided by 33,000 equals to 1.152 horsepower. So 3 decimals tayo, final answer. Okay, so 1.152 horsepower. Okay, so ayun. Diba? Technically, if you know the workaround or kung tanda yung mga formula na na-discuss ko way back, hindi kayo malilito. Diba? Kasi porket nagbigay ng weight, baka imposible na ma-solve. Diba? Which is hindi naman. So may weight naman na siya, 19,000 pounds. May height na tayo na 4 feet. And then, ayun, winark around na lang natin. Okay? So work is equals to weight. Weight yan Weight to. Okay? Weight yan. Hindi yan work times equals to work times height. Okay? So, proceed tayo for another problem. Next. So, ayan. The fourth problem. Okay. A tired squirrel with a mass approximately 1 kilogram does push up by applying a force to elevate its center of mass by 5 centimeter in order to do a mere 50 joule of work. If the tired squirrel does all this work in 2 seconds, then determine its power. Okay, so never mind. So yung mga ganyang problem, mapapansin nyo, ang daming given. Pero nabanggit naman na yung work, which is equal to 0.5 joule. So technically, yun ang gagamitin natin. Di ba? No need to pahirapan yung sarili natin. Okay? So number 4, we have work, which is equal to 0.5 joule. And then we have time na 2 seconds. Okay? So from here, so ayan, di ba? Okay, so from here, technically, so pwede natin makuha agad yung power. So power with respect to time is equal to 0.5 divided by 2 is equal power is equal to ilan yan? 0.125 watts. Diba? Or watt. Watts na lang. W na lang pala. Okay? So, ayan. So, next tayo. Okay, next. Number 5. So, yung number 5, okay, basahin muna natin. Okay, number 5. A 1,000 kilogram car accelerates. Okay? Accelerates for 88 meter per second, 200 meter per second in 30 seconds. How much power does that require? Okay, how much power does that require? So, mapasin niyo yung problem natin, sir, ba't ganun? Dalawa yung velocity. Anong velocity gagamitin natin? So, in this type of problem, di ba, we have two velocity. Of course, we cannot technically use the final velocity. Kasi, kung naalala yung discussion natin last Thursday, kailan tayo nakapag-solve ng final velocity kasi we assume that technically the other velocity is 0. Pero dahil we have value of a first velocity, technically we must get the average velocity. Diba? So, paano pagkuha ng average velocity? Na-discuss naman natin siya, diba? Last midterm. So, let's get, kunin natin yung average velocity, which is equal to VI plus VF, di ba? Over 2. So, VI natin, 88. VF natin is 100. Okay, so 188 divided by 2, which is equal to 94 meter per second. So, meron na tayong mass. So, meron tayong velocity. Okay? Meron na tayong mass na 1,000 kilogram. Okay? And then, meron na tayong time na 30 seconds. Okay. So, paano na yan, sir? Ganun. Diba? So, as what I said, balik tayo dito sa unang diba? Yung work natin, guys, is madami siyang formula. We have force multiplied by distance. We have 1/2 mass times velocity squared. And we have mass times gravity times height. So, syempre, we have mass, we have velocity. Yan ang gagamitin natin formula for work. Okay? So, magiging power is equals to work over time, and then work is equals to 1/2 mv squared, and then technically power is equal to mv squared over 2 multiplied by time. Okay? So, it works. Technically, yung mga unit naman natin in always check the units, guys, baka kasi bigla kayo mag-solve. Pero yun nga, yung unit naman natin, everything is in SI, kilogram, meters, seconds. Okay? So, from that, we can now solve. Okay? So, ayan. So, magiging, yan ang working equation natin. P is equals to 1,000 multiplied by 94 squared all over 2 times 30. Okay? So, 100 times 94 squared divided by 60. So, our work done, power is equals to 14,726.667. Okay? So, ayan. Bali, ano yung mga 5 sample problems natin. Pero, punta tayo muna sa mga units. Punta tayo sa units. Okay? Power, units use. Units use. in power. I-break down natin yung mga units para hindi kayo basta solve ng solve, di ba? Kasi magtaka kayo. So, ayun. So, first, breakdown natin yung joule, di ba? Kasi technically, power is equals to work over time, and then power as a unit of what? Work, joule, di ba? Technically, time is just second. So, in metric pa lang naman to. So, what natin? What is equals to joule per second. Ano ngayon yung joule? Yung joule natin, diba? Joule is technically, tandaan natin, work is equals to force times distance. In essence, yan yung pinaka-basic formula natin. Technically, from that idea, we can come up naman sa mga ibang formula. So, joule is equal to Newton multiplied by meter. Di ba? Kasi, ayan nga. So ayan, di ba? Joule for F Newton, and then distance meter. Next is yung force natin. Force is equal, okay? Di ba? So next, force is equal to mass times acceleration. Di ba? So F Newton, di ba? Mass, syempre, kilogram, acceleration, meter per second. Okay, so ayun nga. So, Newton is equal to kilogram multiplied by meter per second squared. So, kung ipagkasama natin yung mga unit na to, guys, we can come up that what is equal to kilogram times meter per second squared multiplied by meter all over seconds, or equal to kilogram times meter squared over seconds cubed. Okay? So always check your unit. So technically sa English naman, 'di ba? In English, we only have ano ba? The English natin, ano lang naman 'yan. Kindly close your camera. Sa English, 'di ba, ang unit natin is foot pound per minute. So, ang need natin i-break down dyan is yung pound. Kasi yung pound dyan, guys, pound as a force. Okay? So, pound is equals, pound as a force yan, as in pound. So, force, yun yan, di ba? Force, ayan yung ano natin, di ba? So, force is equal to mass times acceleration. In English, F is equals to pounds, mass is slugs, and then acceleration is feet per second squared. Okay? Matik yan. Pag ganyan yung ano natin. Okay? Feet per second squared yan. So, always check yung mass nyo if naka-slugs. Kasi kung yung mass nyo is naka-pound mass, of course, magiging force nyo is magiging pound force. Okay? So, that's all for our topic for power. I hope you learn. Tapos, ayun lang. Thank you, guys. And